Question 11. There was actually quite a bit of questions on here already on similar triangles. Similar triangles. All right. See shown below, trapezoid. All right. Trapezoid. Really had nothing to do with the problem other than knowing that those two were parallel. That's what makes those two triangles similar. All right. And this was you'll see I think this was probably the third question on similar triangles on this work from 1 to 12 only. But if two triangles are similar, their corresponding sides are in proportion. All right, are in proportion. So Zach, what I'm going to ask you to do for me, if you don't mind, we're finding TR. Can you take a side of the small triangle and give it to me? 2. What's the 2 correspond with in the big one? Don't say 4 because that's not a full side. 2.
X minus.
Oh. MP corresponds with what side in the big triangle? MO, which is how long? 6. Everybody good so far? Everyone all right? 2 corresponds with 6. Now, the only other side I have is 9, and that's in the big triangle. So now I got to figure out, doesn't 9 correspond with MT, everyone? Everyone agrees? So how do I write that, though? It's not a number. I don't want to put, I guess I could put X there, but I'm trying to find TR. So look at what I have. I have 9. TR is X. Anybody, how can I relate MT here? How can I write how long MT is so I can plug it in? Because I know this whole thing was 9. This little piece here, I put an X already. So what's MT then, Zach? 9 minus X. And then how do I solve these? Cross multiply. Yep. 6 times 9 minus X equals 18. And then you guys are off to the races. Distribute the 6, solve for X, and you got TR. I don't know I don't know if anybody tried this way or not, but maybe you could, instead of solving for TR, you put the X on MT, and then just at the end, make sure you do 9 minus that to find TR. Okay. All right, other questions here. Let's keep it going. Yep. 5, everyone, take a look. Woo! Oh, yeah. All right, here we go. You said 5?
5 and 6.
Why don't I have 5?
Go 5 first and do 6 times.
I'll run my own class, thanks.
Okay.
Okay, here's number 5. What information is not enough to prove a parallelogram? So I had to know my properties. Done. I got to know my properties or I don't. Okay. What enough to prove the parallelogram? AB congruent to CD, AB parallel to CD. And I'm looking for which one is not enough. That's my special case, if you remember. One pair of opposite sides, parallel and congruent. So that's okay. Let's keep going. AB congruent to CD. BC congruent to DA. Is that a parallelogram? Opposite sides congruent, so that's good. Let's see. AB and CD, BC and AD. Is that good enough? That's not good enough. I got to have either one pair parallel and congruent, or both pair congruent, or both pair parallel. That is not going to cut it. All right, so I got to know my parallelogram facts. And then 6. AD 4, 6. What length of AC makes CD perpendicular to, let's see, AC? Perpendicular to AB. I don't know if anybody noticed what type of question this was. What type of triangle is the whole big one? Right triangle. And then I had this little thing come down, be perpendicular to it. That's referred to as an altitude. Anytime I have a right triangle, altitude to the hypotenuse, this is Hills and Sass. Yep, this is going to be a Hills and Sass question. Never mind. I'm gonna get. Let me just finish 4 then I'll go to 6. Might as well finish it while I'm on here. Hills and Sass. What is CA? What do we call CA back in the day there? Is that a hypotenuse, leg, segment, or altitude? AC. Leg. So I'm definitely going to use hills here. What's the H in hills stand for? What's the length of the entire hypotenuse? 10. Leg X. What do you know about the legs and hills? And what's the S mean? Segment where? I got 2 of them. Adjacent. So what do I want? 6 or 4? 4. X squared equals 40. And then I break down 40, which was what? 4 and 10. So X equals 2 radical 10. All right, so that was a Hill Sass question there. Okay, 6. What's the equation line passes through there in parallel? All right, there's the key to the whole problem there. Parallel. What do I know about the slopes then? Parallel lines have congruent, same, equal slopes. What's the slope of my line right now? 1/2. So the slope of my new line will also be 1/2. The only thing I need to find is what's the y-intercept. And the way I do that is I plug my point and my slope into y equals mx plus solve for b. So it goes through -2, 2. What's my y I'm going to plug in? 2. What's my slope? 1/2 x, -2. Solve for b. Solve for b now. 2 equals, I think that's -1, plus b, 3 equals b. And there it is. Just because I know what's going to hit you on Friday, what if I change that word parallel to perpendicular? Perpendicular. How does this problem change? Instead of having 1/2 right in here, what would I have instead for the slope? Adding? What would I have? Flip and change the sign. Negative reciprocal. So I just wouldn't have 2 in there. I would have -2. Okay, I flip and change the sign if I wrote the word perpendicular instead. All right, others. Addy, go ahead. 2, everybody. This was one of 2 problems that involved partitions. Wonder if it's going to be on there Friday. All right, so I got x and y divided up into a ratio of 1 to 5. Let's start right there. 1 to 5, how many congruent parts then? I got to break this segment up into 6 congruent parts. Let's start by breaking up the x coordinate first. Here we go, x coordinate. I'm going from -6 to 6. How many units is that on the x-axis if you counted? -6 to 6. How many units is that? 12 units. What'd you guys just tell me to divide it up into? 6 congruent parts. So every time I break it up, I go 2 units. What's the first number in the ratio? 1. That's the number of times you got to go 2 units. 2. That's it. So I go 2 units once, right? That's the first number there. So I go 2 units total. Where did I start again? What was my starting x coordinate? -6. So if I'm at -6 and I go 2 units to the right, where do you end up? -4. Yep. I can't answer it yet, right? I got 2 -4s there. All right, what about my y coordinate? Do the same exact procedure now, but -2 to 7. How many units am I going? -2 to 7. How many units is that? That's 9 units, right? Still divided up into how many equal pieces? 6. I think that's 1.5. What's still the first number in the ratio? 1. I don't look at the second number when I do the y coordinate. I look always at the first number. So I'm going to go 1.5 units one time for a total of 1.5 total units. What was my starting y coordinate again? Starting y coordinate? Be careful. What was my starting y coordinate? -2. And I go 1.5 units. Where do I end up? -1/2. So -4, -1/2. All these partition problems done the same way. Just the ratio changes and the points change. Anything else? Go in. Romeo.
Number 3.
All right. Angle H is congruent to angle RDO. I have RD is 4, RO is 6, OH is 4. What's the length of CD? You may not see it, but this is another similar triangle. What's the main way of proving triangles similar? Anybody remember way back in the day? Main way we had. There's 3 ways, but really one main way. Angle, angle. Everyone see a pair of angles here? Where's the other pair? I have a pair of angles that are congruent. Where's the other pair? I'm saying they're similar, but where's the other pair? The one they share, angle R. All right. Okay, Romeo. Same thing I did with Zach here earlier. Give me a side length of the small triangle, please. 4? Now, I got to figure out what the 4 would match up with in the big triangle, right? Now, here's how I notice the 4's in between the 2 congruent angles, right? So go to the big one now. What's in between the 2 congruent angles of the big one? A side length of what?
X.
No. Ready? You see how 4 is in between the 2 congruent angles. Now look at my big right triangle. Here are my 2 congruent angles. What side length is in between those? 10. Everyone else see that? 4 was in between the 2 congruent angles here. So I look at the big triangle. Here are the 2 congruent angles, the side in between. 10. Good so far? All right, now give me another side in the small triangle. 6. Now be careful here. Here's why this problem was tough. You see the 6 is across from that angle? You see the angle that's congruent to it in the big one? H, right? Don't tell me X, because that's not a full side. What's the full side of the big triangle that's across from it? There you go. Now we're on our way. All right. I always look at the congruent angles and look across from them. That'll always tell me what sides match up. Always. So use your congruent angles to figure out the sides that should match up. And then you should be on your way. Other questions? Yep. 12, everybody. Going deep. All right, we were given that A was congruent to EDF and has already proven AB congruent to DE. What other pair of corresponding parts would not prove the triangle's congruent? All right, everyone ready? Let's see, if I had AC congruent to DF, would that be side, angle, side? If I had those two, side, angle, side, angle in the middle, we're good there. I'm looking for which one's not. Let's try number 2. BC congruent to EF, side, angle, side. Why not? Angle's not in the middle, right? So there we go. All right, angle's not in the middle, unfortunately, so I can't choose that one. Anything else? The only thing you guys didn't ask, and it came up, I think, twice, maybe not twice, sine, cosine, tangent. SOHCAHTOA, that came up last night, so probably expect that, right? Nothing else? All right, look, you know it's coming Friday. I'm not hounding you. I'm not going to hound you about doing the homework. I'm not even going to hound you right now if you want to practice or not. You know Friday's coming. 20 questions. You got to answer 15 of them. If you get more than 15 right, it's a 1-point bonus every time. It is not Q1 and Q2. It's not. You guys are seeing that already pretty quickly. 3 quarters worth of material here. All right. All right, so here's the deal now. You guys are on number 13, right? We're doing 13 through 21. 13 through 21. That's the goal and the questions I'll be answering tomorrow. 13 through 21. Okay, 13 through 21. If you have any questions, let me know. I'm going to take away the right or wrong here until tomorrow. Sorry about that, but. So if you're concerned, if you got one right or wrong, let me know. If you are going to work with somebody else, I'm going to let you know it better be on this and not just something else. So hopefully you can handle that if you're going to pair up with somebody. Because nobody cares what's going on outside of class.